This video is for topic 9-2 over solving systems of equations by graphing day 2. The first question tells us that a scientist studied the weights of two alligators over a period of 12 months, and they ask us to use the tables below to determine the initial weight and rate of growth for the first and second alligator, and after how many months did they weigh the same amount. So first thing we're going to do is label the x and the y axis. Your x is whatever your first thing in the table is, so months. And then weight would be off to the left side. Now, part of this has already been done for us. Anytime we see a table, we first need to check and see if I have any x's and y's that are exactly the same. So when I check the zeros, they're not the same, ones are not the same, twos are not the same, and threes are not the same. Because they're not the same, that means I need to go ahead and put this table in stat edit, and they've already done that for us. So they put just this table into stat edit and found the equation, and then just this table into stat edit and found that equation. So the green one has already been graphed for us. The blue one has already been graphed for us. We're going to graph the green. For the green one, we start at 6 and we go up one, right one, up one, right one, up one, right one, until our little dots cross. And this is alligator 2. Now we can see our dots are crossing here, so that is the point of intersection, where after that many months they weigh the exact same. The question was after how many months, so this would be 4 months. The alligators both weigh 10 pounds, or 10 whatever weights. Problem 2 asks us for the solution to the system of equations below. So we are looking at two graphs here. Again, I can put these in stat edit, but before I do that, I'm going to check and see if any of my x's line up with y's on the other table. So here I have an x of -6, but I don't have any of those. -2, but I don't have that. 0 I have on both tables, but my y's are not the same. Here it's -4, here it's 1. 3 is 2, and 3 is 2. So without having to use stat edit, we have a solution. So the 0.32 simultaneously fits both equations. So for these two equations, it works in both, it shows up in both tables, and so it's going to work for both of these. It could also say satisfies instead of fits. So the 0.32 fits or satisfies both equations because it's in both tables. Today, when we're looking at graphing in the calculator, these are going to be our steps. I'm going to walk you through them, but anything that I'm talking about is going to be right here. We have to change things into y equals, put them into y equals in the calculator, and again, you can't put it into y equals unless your form is in y equals. Plug it into the calculator, second, calc 5, enter, enter, enter 3 times. Yes, you do have to do it 3 times. If you do not do it 3 times, you will get the wrong answer. And then once you have done that, you should have your answer. When I plug my equations in, I always plug them in from whatever I see on top, plug that into y1, whatever I see on bottom, put that into y2. You'll see in a second when we look at our tables, y1 and y2, the order matters, and so it really will help if you can pick a way to plug them in and stick with it. On problem 3, they have helped us out by starting to solve for y, but they have not finished. So on the left side, everything canceled except for the y. On the right side, I have -4x plus 3. Remember that x and 3 are not like terms. One is a letter, one is a number, so I cannot put them together. In my table, I'm going to put this exactly like I see it into stat edit and follow those steps that we've done before to get my equation there. So there's nothing I can solve for or do here. I'm just going to plug straight into stat edit. So I click the stat button on my calculator. Remember the stat button, once it loads, is the one under delete. So stat edit. This table is already put in here. I would put all of my x's in L1, all of my y's in L2. The table in my calculator looks exactly like the table on my paper. Once you have entered these, you click Stat, Calc 4, enter, 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 and we get our equation 3x minus 4. It is not a -4, it is a -4. The only time you will have negatives is if they come before a number. So like if the 3 was a minus, then it would be a negative. Otherwise, it's just read as a minus sign, not a negative sign. So do not use negatives unless they need to go in the very front. So in y equals, I'm going to put this in y1 and this in y2, and I'm going to put them in that order so I do not mess up. So in my calculator, y equals is the top left button up here. In y1, I am typing negative 4x plus 3. I put the negative in front on the first one because it is in front. The second one is 3x minus 4. So this time I use a minus sign because it's not in front. So in y1 we had a negative out front. On y2 we had a minus in the back. From here I will click graph and I can see exactly where my lines are going. Remember when we did functions, if you click second graph, you can see the table. And this is where it's really important because they label these y1 and y2. It is very important for you to know which one is in which column. So you need to make sure you know what are you putting into y1 and what are you putting into y2. From the graph, I'm going to follow the steps up. This is step 3 up on the top of your paper. So second, trace. 5, enter 3 times. The first time it says first curve, so I click enter. The second time it says second curve, so I hit enter again. When it says guess, I hit enter again. Until you see the word intersection, you need to keep hitting enter. So my intersection is at 1, -1. So that is my solution because that is where those lines cross. And I can draw just kind of a rough graph. y1 starts positive and goes negative. y2 starts at a negative and goes positive. And they cross at 1, -1. For problem 4, the green equation has already been solved all the way for us. That is the second one that we see, so we will use that for y2 or g of x. We need to solve for the blue one, so I move x to the other side. And I have -3y equals -x plus 6. From here, I divide every piece by -3. So negative divided by negative is positive. 6 divided by -3 is a -2. So in y1, I'm going to put 1/3 x minus 2. In y2, I'm going to put 1/3 x plus 1. So I come back up to y equals. I'm going to clear out what's in there. In y1, I'm going to click alpha, zoom, and put in the fraction 1/3. X minus 2. And then alpha y equals 1/3 x plus 1. So I've put them in y1 and y2. When I click graph, look at what happens. My lines never, ever, ever cross. The reason they never cross is because they are parallel. So on my paper, I can draw my 2 lines, and these will have no solution because my solution is the point where they cross. If they never, ever cross, then I will never, ever have a solution. For our last problem, we're not going to use a calculator because we cannot put the top equation into y equals. The reason I cannot put the top equation into y equals is because there is no y equals. I have x plus 9 equals 3. This is a special case because I only have one letter. In order to solve, I try to get x by itself, so I move 9 to the other side. X equals -6. So when I graph this, this is a Vux. I just estimate, go over to -6-ish, and draw a straight up and down vertical line because that's what a Vux is. My second equation is a line parallel to the y-axis that goes through the point -2, 5. So I'm going to plot that point. It's a little rough, but just plot it. Perpendicular to the y-axis means it's going to go through the y-axis, cross through the y-axis. So that means this is going to be a HOI. Because I have a HOI, I need y to equal the y point of my point. So my first equation was x equals -6. My second equation was y equals 5. Wherever they cross, when you have two special cases, it's just going to be the x point and the y point. So -6, +5. This is an exit ticket that we did in class in order to get to work on your homework. So I'm going to run through these very quickly with you. If you want to pause the video and try to do them yourself and then come back and see if you get them right, that's fine too. I'm going to start with some of the graphed easier ones. Not having a solution means that these are parallel. My parallel lines are E because these are never, ever, 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 ever going to cross. B looks like it has a solution down something. So the solution is 0, negative something. So 5 would be B. This one looks like it goes over 2, down 1. So that would be 3. And then I have 2 tables left, so the solution is -1, 2, or infinitely many solutions. So looking at C, I'm trying to see, do I see a point where they're the same? Oh, well, they're the same here. They're the same here, and here, and here, and here, and here. So because all of my points are exactly the same on C, all of my points, like the y2 matches exactly with y1, this is going to be infinitely many solutions. And so D must have a solution at -1, 2. I double check, and x is -1, y's are the same. So D, E, A, C, B are your correct answers there.